Hello everyone. In this video, we are going to talk about obtaining new functions from old functions. So naturally, if we have two functions like f and g, which are functions, they can be used to get new functions like f plus g, or f minus g, or f times g, or f over g, and these give really new functions. For instance, we can talk about like some examples like, let's say, if f of x is equal to 2x, and let's say g of x is equal to x squared, then f plus g, we can write it like this way, f plus g, which means f of x plus g of x, and that's equal to 2x plus x squared. Or we can talk about f minus g here, and then that means f of x minus g of x, which is 2x minus x squared. And then, of course, f times g. Sometimes we write the dot between f and g, but we don't write usually. But that only means f times g. So that means f of x times g of x. And that's 2x times x squared, which is 2x cubed. Here, x is input, of course, right? X input, f, g functions. Of course, we can also talk about f over g. That means f of x over g of x. That's 2x over x squared, or 2 over x. And as you see, each are new functions, and we obtain them from two functions just by using four basic operations: summation, subtraction, multiplication, and division. Another example is, which is an important example. So these are polynomials. Let's say we have f1 equals some constant, and then f2 equals some other constant a1 times x, and then f3 of x equals some new constant a2 times x squared, f4 of x equals a3 times x cubed. And if we can go and continue writing functions like this, so I want to write f of n plus 1. That's going to be equal f of n plus 1 of x is equal to an plus 1, well, an xn. And then we can talk about summations of all these functions. So f can be written as f of 1 plus f1, f2, f3, all the way up to fn plus 1. So that's going to give us a0 plus a1x plus a2x squared plus a3x cubed plus all the way up to an xn. Okay, here each ai is a constant real number, and as you see, n goes from 0, 1, 2, 3, natural number. So if we have a combination of functions like this is called polynomial. So just an example for this. like x, 2x plus 1. This is a polynomial. Or you can think about x squared minus 2x plus 3. Or you can have something like 5x to the 7th minus x to the 6th plus 8x to the 5th minus or plus 3x to the 4th plus 10x cubed minus x squared plus x minus, let's say, 9. Okay, this is another polynomial. Okay, these are, of course, important functions, these polynomials are. And as you see, they come as combinations of functions. So we multiply two functions. For instance, we multiply 5 and x to the 7. And then we subtract this new function from, well, we subtract x to the 6 from this function. And then we add another function like 8 times x to the 5th. And we keep going like this, and we obtain polynomials. However, if we have something like this, let's say 5x to the 1 over 2 minus x squared. This is not a polynomial. Why? Because the power functions we have, like one of them is x to the 1 over 2. This is not a natural number, not a counting number. So we want all the powers to be natural numbers. So if you have something like this, like 5x to the 1 over 2 minus x squared, this is not a polynomial, but it's just a combination of two functions, like 5 times square root of x minus x squared, but it's not a polynomial. Another example is rational functions. So rational functions are like if f of x and g of x are two polynomials, then their quotient let's call this r of x to remind us that this is going to be a rational function. And this is called a rational function. So a rational function is a quotient of two polynomials. Okay, we want the functions, numerator and the denominator, to be polynomials. So as an example for this, let's say x squared minus 4x over, let's say, x cubed plus 2x minus 7. This is a rational function. We can increase examples like this. Okay. Another way to get new functions is composition of functions. So compositions of functions are defined like this. If f of x and g of x are two functions, then composition of them is defined this way. F composition G, this all-looking operator means composition. It's defined as f of g of x. This is another way of obtaining new functions, and this is actually more common than most other functions we can think about. So as an example, let's say f of x is square root of x, and let's say g of x is x squared minus 3, then f composition g can be written this way. First, we take g of x, so we take an input. So here maybe I want to write like this: x input, then apply g, then apply f. So we apply g to the input, and then we apply f to the g of x. So what's going to happen here? First, we take input x, we apply g, x will be x squared minus 3 because that's the rule of g of x. And then we will apply f to x squared minus 3. What is f? It's square root. So it takes any input, takes its square root. So if the input is x squared minus 3, then it's going to take its square root, and this is f of g of x. What about g of f of x? Now this one, it's going to take f of the input, which will make the input x to be equal to square root of x because f takes square root. And then what does g do? It takes the square of the input and then subtracts 3. So what is the square of square root? It's x minus 3. So this is g of f. Well, we can talk about f of f, like f composition f. What will it mean? So first, it's going to apply f to the input x, which will be square root. And then applying f again will take another square root. What is the square root of square root? Let's write slowly. Like square root is power 1 over 2. Another square root is also 1 over 2. So if we have power over a power, we multiply the powers. And that gives us x to the 1 over 4. So this is equal to 4th root of x. And this is f of x. Also, let's think about g of x. So we will first apply g to the input, which will make x, the input x, to be equal to x squared minus 3. But applying g again will be taking the square of the input. Now the new input is x squared minus 3. So we will take its square and subtract 3 again. Now if we take the square here, it's going to be x to the 4th, double of the product, which is x squared times minus 3, negative 3x squared. But double of that, because we are going to have two of them, negative 6x squared, square of minus 3 plus 9, minus 3. So we can write x to the 4th minus 6x squared plus 6. And this is g of x. Okay, so this is a very important way of obtaining functions. So what happens is we start with some x. Let's say we are talking about f of g of x. So that means f of g of x. So first we will apply f, and then x will be f of, we will apply g first. It will be g of x. And then we will apply f to this, and it will be f of g of x. Okay, so watch the order. After the input x, there is g, and then f. So we first apply g and then apply f, and we get f of g of x. Okay. Okay. Another way of obtaining new functions is actually like doing these compositions. By the way, another example is algebraic functions. So algebraic functions are kind of like rational functions. So what happens is, for instance, if we take like, if we obtain a function f in the way using algebraic operations, then it's called an algebraic function. So a function f is called an algebraic function if f can be obtained using algebraic operations such as addition, subtraction, multiplication, division, or taking roots. Taking roots also an algebraic operation. So any function like that is going to be an algebraic function. So an example for this is like the one we had, like x squared minus 3, square root of x squared minus. This is an algebraic function because we have uh, x times x, it's a multiplication, and then a subtraction, minus 3 subtraction, and then taking square root. So all these operations are algebraic operations, and what we get is an algebraic function. Or let's say we have something like this, like x cubed minus 7x squared over, let's say, x plus square root of x. That's another algebraic function because we have x times x multiplication, and then x times x, x squared, multiplying it by minus 7 and combining these two. It's all algebraic operations. And then dividing it by something like x plus square root of x. All these can be done by algebraic operations. So this is an algebraic function. So that's another way of obtaining functions. And then the other way of obtaining functions are, transformations. So what do I mean? I mean like shiftings, for instance, vertical and horizontal shifts. For instance, like y equals f of x plus c, let's say. This shifts the graph of f uh, y equals f of x a distance c upwards. So like if we have, let's say, this is, let's say, y equals f of x, then if we add c to this, then this is going to be y equals f of x plus c. So this distance here is c, okay? Or we can have a subtraction that shifts f c units downwards. So let's say if this is f, and if we are shifting it by something like c, then we are going to have a graph like this. Okay, subtracting c from all the outputs are going to give us smaller outputs, or adding c to the outputs will give bigger outputs, the first case. Okay, and or we can do shiftings with the x, like we can have y equals f of x minus c, let's say. Now, this is also a shifting, but in the x direction. So let's say this is y, this is x. This shifts f c units to the right. So it's going to be something like this. If, let's say, this is y equals f of x, and let's say we shift it by c, then it's going to give us this function. Okay, how do I know that this is a right shifting, by the way? If we think about it, like let's say this is y equals x squared. If we write x minus 2 squared, then x squared is going to look like this. Let me erase this part. Let's say this is y equals x squared. But if I write y equals x minus 2 squared, then it's going to be something like this. And then this is going to be 2. In the other one, y equals x squared, like if x is 0, then y is 0. But think about y equals x minus 2 squared. Then if x is 2, then what's going to happen? 2 minus 2, which is y squared. This is going to be 0 squared, and it's going to hit 0 when x is 2. Okay? But in the previous one, if you give x equals 0, then y is also going to be 0, this point here. But in this one, if you give x equals 2, then 2 minus 2 is 0, and 0 squared is 0, and y is 0 there. Okay, so this point is 0, 0, but this point is 2, 0. Okay, so if you subtract 2 from x, then the graph will shift 2 units to the right. And then similarly, y equals f of x plus c shifts f c units to left, just like the third case. So it's going to be something like this. Let's say this is y equals f of x, and then if you add c to x and then apply f, then the graph will shift like this. Okay, like for instance, if we have x squared again, but if we write x plus 3 squared, think about it. In this one, this point here is again 0, 0. But in the other one, if you give x equals minus 3, then minus 3 plus 3 squared will be 0 squared, which is 0, and that's equal to 1. So this new one will be this graph. Minus 3, 0, and the graph of f, x squared function, shifted 3 units to the left. Okay, similar to this, we can have stretchings and reflections. So this is multiplying by a constant, by the way. And we can also have reflections. I will show all of them. For instance, let's say we have y equals c times f. What's gonna have? What's gonna have? I mean, what's the effect of this gonna be? It's gonna stretch the graph. Let's say c is something bigger than 1. Let's say, okay, this is gonna stretch the graph of f vertically by a factor of c. So let me give an example here. Let's say y equals x squared. It looks like this. But if you multiply by, let's say, 2, then you are going to stretch it like this, 2x squared. Okay. If you multiply it by 3, it's going to be even bigger. Okay. So it's a new way of obtaining functions. But let's say if we have 1 over c times f, then this shrinks f vertically by a factor of c. So again, similar example. Let's say we have x squared So if you multiply this by, let's say, 1 over 3, then it's going to be something like this. Okay, this is y equals, let's say, 1 over 3 x squared. Well, it shrinks vertically by a factor of c. In this case, c is 3. So we are multiplying by 1 over 3, and we get something like this. And also we can play with x here. Y equals f of c times x. So this one shrinks f. Now horizontally though, horizontally by a factor of c. For instance, let's say uh, we have y equals x squared. Now if we have something like this, y equals 2x squared, then this is going to be 4x squared. Okay, then we are going to have something like this. Okay, it does faster than the x squared, like 2x squared does faster what y equals x squared does. Okay, or a better example might be this. Let's say we have sine function. Okay, so this is 0, pi, 2 pi, and the function is sine of x. So if we have, let's say, y equals sine of 2x, then what's going to happen is this. It's going to do faster. Something like this. So this time it's going to hit 0 at, twice, like the second time at pi over 2, and the third time at pi. Okay, it's going to do twice the faster what sine of x does. Okay, so this one, the graph of this function is going to do twice faster what sine of x does. And then similar to this, we can have y equals f of x over c. This will have the opposite effect. This stretches the graph of f horizontally by a factor of c. So again, let me show you with this sine functions graph because it's going to be better to observe. So let's say this is sine function 0, pi, 2 pi, and this is plus 1, and this is minus 1. So let's say we have, this is y equals sine of x. If we have y equals sine of x over 2, then this is going to look like this. It's going to be twice slower. So it's going to come to 2 pi the second time. And then it will go to 4 pi when it hits the x-axis the third time after 0. Okay, so it's going to be this. Okay, twice slower. Dividing x by 2, okay, will make that. And then there are two more effects of like transformations. These are reflections, y equals minus f of x. So this will reflect f with respect to x-axis. Because y, let's think about it. Let's say y equals x squared. If we have y equals minus x squared, then we are going to multiply all of the outputs by a negative. So the outputs will be reflected like this. This is y equals minus x squared. Okay. And there is one more. And that's y of f of minus x. So this one reflects f with respect to y-axis. But I want to show it with a different graph. Okay, so let's use the sine of x function, or let's use square root of x. Okay, this is, let's say, y equals square root of x. This is the usual function we know, x, y. But if we take y equals square root of minus x, then it's going to be defined for negative numbers, because let's say here minus 1. It's going to be minus 1 plus 1. Square root of plus 1 will be 1. But this one will happen for 1. Okay? So it's just going to be a reflection with respect to the y-axis. And these are ways of obtaining new functions.